Yeah, good evening, children. Good evening, Srijit. I've shared my screen.
Good evening,
is it visible?
ma'am.
Yeah, I've shared my screen. Is it visible, Srijit?
Yes, ma'am. Yes, ma'am.
Very good. All right. So I think we finished before the vacations. We finished this chapter, understanding quadrilaterals. We have the revision part remaining there. But today we are starting a new chapter, squares and square roots. Okay. Slowly. Don't make so much of noise. Yeah, the spread.
Ma'am, we should copy this, ma'am.
No. I'll give you instructions. Please wait.
Okay. Okay, ma'am.
Spread. Yeah. Focus. Yeah. So the chapter is called squares and square roots. So we'll understand the meanings of the terms in the name of the chapter, squares and square roots. Okay. So for that, we'll just consider this mathematical equation. 16 into 16 is equal to 256. Listen first, you don't have to write anything. Okay. 16 into 16. 16 multiplied by 16 is equal to 256 is a mathematical equation. It's a mathematical equation. Now here, 256 is said to be the square of 16. And 16 is said to be the square root of 256. We'll take another example. 7 into 7 is equal to 49. In this mathematical equation, 49 is said to be the square of 7. And 7 is said to be the square root of 49. Another example. 12 into 12 is equal to 144. So in this mathematical equation, 144 is the square of 12. And 12 is the square root of 144. All right. Now, we will be using this symbol in this chapter. This symbol, see, you will have to draw it like this or write it like this. Okay. So this symbol is read as the square root of. The square root of. Okay, tell me what this symbol, how this symbol is read as. What? Is equal to. Correct. Is equal to. Is equal to. Is equal to. Is equal to. In the same way, this symbol. See, in the print, it looks like this. It's, you don't have to, like write it like that. It's just like this V and like this. All right. Okay. The square root of. So if you write, say, 100 here, the square root of 100. The symbol itself is read as the square root of 100. When you see the symbol, how will you read it? The square root of. And there's a number here, 49. The square root of 49. Okay. Okay. So symbolically, we saw something here, no? Symbolically, we say 16 squared. 16 squared. Squared. 16 squared is equal to 256. That is 16 into 16. 16 squared meaning 16 multiplied with itself. Okay, so 16 squared is equal to 256 because 16 into 16 is equal to 256. And the square root of 256 is equal to 16. That's what we understood here. That's what we understood here. 256 is said to be the square of 16. No, so how do you write the square of 16? See, square of 16 is written like this. Square of 16. And it is read as 16 squared. 16 squared is equal to 256. Here, this line. Symbolically, this line is written. This line in English is written like this, symbolically. The square of 16 is equal to 256 is written as, see here, square of 16 is equal to 256. It is also read as 16 squared is equal to 256. And what is it here? The square root of 256 is 16. the square root of 256 is 16 or is equal to 16. Okay. So now tell me, what is the square root of 36? What is the square root of 36? 6. Very good. What is the square root of 121? 11. What is the square root of 400? 20. Because the square root of 4 is 2. And when you have two zeros, the square root will have, when the number has two zeros, its square root will have half the number of zeros. So two zeros, so half of it, 1 0, 20. What's the square root of 900? 30. 9 is 3, 2 zeros, 1 0. Half the number of zeros. 30. 30 into 30 is, so square root of 900 is 30. Square root of 900, the square root of 900 is 30. That means what? 30 into 30 is 900. Yeah, or 30 squared is 900. Correct. 30 into 30 is 900 or 30 squared is 900. So now, so what do you mean by the square of a number? The square of a number is the product of the number multiplied by itself. What do you mean by the square of a number? Okay, it's a square is a product. When you have to find the square of a number, you should find a product. So it's the product of the number multiplied with itself. Okay, for example, the square of 12. Supposing they ask you to find the square of 12. That means you should do 12 into 12. Square, to find the square of a number, you should find the product of the number with itself. The square of 12 is 12 into 12, which is 144. Symbolically, 12 squared is 144. It's a repetition. See, here we saw, I just introduced the terms to you. So now we are seeing it in terms of definitions. All right. Okay. So the square of a number is the product of the number multiplied by itself. The square of 12 means multiply 12 with itself. So 12 into 12. And the product is 144. Symbolically, 12 squared or the square of 12. See, how do you read? You can read this in two ways. The square of 12 or 12 squared. 12 squared or the square of 12 is 144. Next. What do you mean by a perfect square or a square number? What do you mean by a perfect square or a square number? A number is said to be a perfect square or a square number if it is a square of some other natural number. Now, for example, 100. 100 is said to be a perfect square because it is a square of 10. It's a square of some other natural number. A number is said to be a perfect square if it is the square of some other natural number. You will understand, you'll get used to it. See here. Now, for example, 144. Now, 144 is a perfect square because it is the square of some other natural number, 12. 12 squared is 144. What is a perfect square or a square number? A number is said to be a perfect square or a square number if it is a square of some other natural number. So 9 is a perfect square or a square number. Why? Because it is the square of some other natural number, which is 3. (25) is a perfect square or a square number because it is the square of a different natural number, 5. That's it. No. Now 6. The square of no natural number is 6. The square of no natural number is 6. Now, when you say 3 square, it is not 3 into 2. It's not 3 into 2. Just a minute, Srijit. 1 second. Yeah, thank you, children. Thank you, Srijat. Thank you. Now, don't leave the call. Thanks for waiting patiently. Okay. So we were here. Yeah. For example, um, 64 is a perfect square or a square number as it can be written as 8 square, where 8 is a natural number. Explanation. Okay. Now, the other thing. Understood so far? Okay. Now, next. Every square number will end with a digit 0, 1, 4, 5, 6, or 9. If a number is, like a perfect square, then it will end with one of these digits. But that doesn't mean that every number that ends with one of these digits will be a perfect square. Now, for example, 64 ends with the digit 4. It's a perfect square. That does not mean 54, 44, 34, 24, all these are perfect squares. No, no, no. Every number that ends with 4 is not a perfect square. If the number is a perfect square, then it will end with one of these digits. Now, supposing I give you a number like 9673792, and and the question is, can this number be a perfect square? You will say no, it cannot be a perfect square. Why? Because it ends with 2. No perfect square will end with the digit 2, like that. But if it ends with 4, you should not say it is a perfect square. It may be a perfect square. It may be. You cannot say it is a perfect square. It may be a perfect square. And that you can confirm only by finding its square root. We'll come to that later. So if a number ends with the digit 2, 3, 7, or 8, then it is not a perfect square because those are the digits missing here. 0, 1, 2, 3, 4, 5, 6 is here, 7, 8. 2, 3, 7, 8. 2, 3, 7, 8. Remember, 2, 3, 7, 8. Numbers ending with the digit, last digit, ending with the digit. Numbers ending with the digit 2 or 3 or 7 or 8 cannot be a perfect square. Numbers that end with the digits 0, 1, 4, 5, 6 or 9 may be a perfect square. Perfect squares will end with only these digits. May or may not be. Because as I just told you, in the case of 64, it ends with 4 and it is a perfect square. 144, it ends with 4. It is a perfect square. 104 ends with 4. It's not a perfect square. Because no number multiplied with itself will give you 104. Now 13 8s are 104. 13 8s are is 104. Yeah, not a number multiplied by some other number. Number multiplied with itself should give you 104. A natural number multiplied with itself should give you 104. No, there is no such natural number which when multiplied with itself will produce 104 as a result. Yes, yes. We'll come to all the later. No, still, you see, if supposing it was 1.44, okay, it's a perfect square because it is 1.2 into 1.2. So you're saying like some decimal number that also will not be terminating decimal. That also will be a non-terminating decimal. Yeah. So when you ask a question beyond what we are learning now, no, it's difficult for me to answer precisely. Your question is valid. So when we come to that part of the chapter, I can explain it better. Now we are just in the introduction part. And when you're asking me a question, 4, 5 sessions later, it's difficult for me to answer you correctly, clearly, not correctly, clearly. So we'll just put that on hold. Yeah. Then every number that ends with 0, 1, 4, 5, 6 or 9 need not be a perfect square. numbers that end with 2, 3, 7, or 8 will always be an imperfect square number. Imperfect square number. Understood that? Understood all these? Okay. So now this is 1 squared, which is 1 into 1. 1. 2 squared, 2 into 2, 4. 3 squared, 3 into 3. Because 3 squared means what? 3 into 3, 9, and so on. Okay. So these images I'll share with you on WhatsApp later. You'll have to complete all this. You're not writing now. Yes. Now, when 0 into 0 is actually a discussion. Again, that will not do now. This is a discussion because we can say for it and against it. So no, just leave that. So here I've shared this chart. I want you to memorize this. I want you to memorize this. So next class we'll have a oral test or an oral quiz. So here I have tabulated the squares of natural numbers from 1 to 50. 1 to 50. Okay, so let me make it easier. I 1 to 50, right? Okay, no. 1 to 100. Okay, I have it from 1 to 50 here in the first table, and the second table from 51 to 100. So let's do this one for the next class. Write everything. When I share the images on WhatsApp, please complete everything in your notebook. But for the next class, memorize the squares of the natural numbers from 1 to 50. If I ask you what is 49 squared, you must say 240. Like that. All right. See, the questions can be only of two types. Either I'll ask you, what is the square root of 784? Or I'll ask you, what is the square of 37? What is the square of 37? So what is the square of 37? 1369. What is the square root of 2209? 47. What is the square of 5? 25. What is the square root of 225? 15. No. One?
Like 13 square only or like
No, both. Only till 25, huh? No, you can. Okay, fine. No, that'll be very simple. No, 1 to 30, you can easily. Okay, fine, I'll go with you. Okay, 1 to 30. Okay, you do one thing. 1 to 30, you learn perfectly. 30 to 50, just I'll not ask you many from between 30 and 50. I'll ask most of the questions from 1 to 30. So you concentrate on that. And also try 30 to 50. We'll see how much you can handle. Okay. So these are some important rules. So these rules, for now, you just understand. When we apply, you will be able to relate and understand better. Okay, now see here. Square root of A plus square root of B is not equal to square root of A plus B. Square root of A plus square root of B is not equal to square root of A plus B. That means if you have, if it's like square root of 25 plus square root of 16, square root of 25 plus square root of 15, it is not equal to square root of 25 plus 16. This is wrong. Okay, so if square root of 25 plus square root of 16 should not be written as square root of 25 plus 16. This is wrong. Okay, next. Square root of A minus square root of B is not equal to square root of A minus B. This is the next rule. But for multiplication and division, it's okay. Square root of A into square root of B is equal to square root of A into B. True. Sorry? Yeah, any number you can take. You can take any number actually. I've just taken 20 and 5. You can write any number. Similarly, square root of A by square root of B can be written as square root of A by B. So addition, subtraction, no. Multiplication, division, yes. We'll do it again. Square root of A plus square root of B is equal to square root of A. Sorry, it's not equal to square root of A plus B. Square root of A minus square root of B is not equal to square root of A minus B. Square root of A into square root of B is equal to square root of A into B. Square root of A by square root of B is equal to square root of A by B. Is it okay, Srijit?
Yes, ma'am.
Okay. Is it fine?
Yes, ma'am.
Yeah, good, good. Yes, here? Very good.
Ma'am, we should copy this, ma'am.
No, Srijit. I'll be sharing all these images on WhatsApp with you. Just a minute.
Okay, ma'am.
I'm just talking to somebody in the class here. Just a minute. Yeah. Yeah, now leave that. That's over. Now come to the class. Understood, children? Any questions? Navneet? No. Yes, yes. Which one? Huh? How is it possible? No, I'm not getting your question. Oh, you're saying under the square root, there should be a perfect square only. No, it's not like that. You can see now square root of 49 is 7, right? Now we can also find square root of 50. You will be learning that also. We uh, square root of 49. Now 49 is a perfect square. So for 49, you'll have a precise value. But square root of 50, 50 is not a perfect square. So it's square root, you can find its square root approximately to some number of decimal places. You can find the approximate value of square root of 50. Now you can find the exact value for square root of 49. Square root of 49, you can get the exact value, 7. But square root of 50, there's no exact value because no number multiplied with itself can give you 50. But you can find some approximate value. So your question is under the square root. It's not that there should be a perfect square. There can be an imperfect square also under the square. Was that your question? So those results are here. Okay. Same thing, what I just explained. Correct? Correct? Yeah. Yeah. So leave some space. Start working from here. So leave count. Help yourself. We'll have to write down this one, and this one. Okay, so that's free work.
Ma'am, how many pages should we leave?
See, depending on the size of your notebook, Srijit, I'll just show you the contents. This one you should write. 1,
Okay, ma'am.
2.
Okay, ma'am.
Then this one.
Okay, ma'am.
This and this. So you leave according to the size of your notebook, your page, you can decide how much you leave. Leave some space extra, that's okay. But கம்மியாயிட விட்டு congested ஆயிட போறது பாத்துக்கோ. Done, children? Shall we start? Yeah. Find this, write on the question. Now it's writing from now. Find the square of 30. Yeah, squares and square roots. Yes. Squares and square roots. Write the answer as you see on the screen. The square of 30 means 30 squared. The square of 30 means 30 squared. So that means 30 into 30, which is 900. Okay. Done? Srijit?
I'm 1 minute back.
Okay. Okay. Next one. Yeah. Find the square root of 900. Find the square root of 900. So we'll first learn how to find the square root of 900 using the prime factorization method. Okay, using the prime factorization method. No. 1 minute. Listen. So see here. Now you must use only prime numbers. So we'll start with 2. 2 450 times. 2 225 times. 3. Okay, it's divisible by 3. 3 7s are 21. 1 3 5s are. Then again 3 25 times. For any, you can use 5 also. No, you said 3. No, you said 5 and I said 3. You can use 5. Where I've used 3, you can use 5 also, I said. Then 5, 1. All right. Now see the next step. So 900 is equal to 2 squared into 3 squared into 5 squared. Is this understood? Because 2 into 2 means 2 squared. 3 into 3 means 3 squared. 5 into 5 means 5 squared. Now see the next step. Write the step again. Write the step again. Write the step again and take square root on both the sides. Write the step, repeat that step, and now take square root on both the sides like this. Understood? Taking square root on both the sides. Is that understood? First write the step, repeat that, and take the square root symbol on both the sides. Now next, the square root of 900 will come as it is. Look at the board. Square root of 900 as it is equal to, on the right hand side, how do you get rid of the square root symbol? From 2 equal factors, bring 1 out. That is how you get rid of the square root symbol. See, we want to find the square root of 900. No, so let this be there. See, the square root of 900 we have written here. Okay. Now on the right hand side, we have to get rid of the square root symbol. How do we do that? From 2 equal factors, bring 1 out. So see here, from 2 2s, write only 1 2. From 2 3s, write only 1 3. From 2 5s, write only 1 5. Now you need not put the square root symbol. You need not put the square root symbol. To get rid of the square root symbol, from two equal factors, bring one out. So from 2 2s, 1 2 out. From 2 3s, 1 3 out. From 2 5s, 1 5 out. Now you don't have to put the square root symbol. Next step, square root of 900 is equal to 2 3 are 6, 6 5 are 30. See, we got it. We all know 13 to 30 is 900. But this is how you show the steps. Understood? Yeah. Right on. Past 8th standard, so I'll not wait for all of you to complete. I'll just wait for some time and then keep moving to the next one. You have to improve your pace of writing.
Just removing the fact that can you say this removing the fact can you say that?
Yeah, I said to get rid of the square root symbol எடுக்கணும்னா ரெண்டு equal factors சேர்ந்து one will come out. Finished? Yeah.
Yes, ma'am.
Okay. Yeah. Try this yourself. Find the square root of 14,641 by the prime factorization method. Check if it's divisible by 2, then 3. Go in the order. 2, 3, then 5, then 7, 11. See, now it's not divisible by 2, no? So it'll never be divisible by 2. You don't have to check 2 again. Then check if it's divisible by 3. If it is not, no? Even if after you start the division process, it will never be divisible by 3. You don't have to check 3 again. Yeah. Got it? Got it? Yeah, what's answer? 1? Perfect. Have you presented all the steps? Very good. Finish the prime factorization, both of you? Yeah, Dhanvin and Srijit?
No, ma'am. 1 minute.
Okay. What's the first prime number you've tried, Dhanvin? Or Srijit?
Ma'am, 3.
3.
Yeah.
10 plus 4, 14 plus 2, 16. 1 plus 4 plus 6 plus 4 plus 1 is 16. 16 is not divisible by 3. So this number is also not divisible by 3.
Ma'am, no, ma'am. I didn't write 4 in that.
Oh. Okay. Yes, sir. Tell me. 11. How many times? 1? Okay, stop. Next, Navneet, what's the next prime you've taken? What's the next prime number you've taken? 11. What's the quotient? 121. Next, Anirudh? 11. What's the quotient? 11. Again, how do you finish it? 11 and 1. Yes. So what's the first step? 11 square into 11 square. 11 square into 11 square. Now you should repeat that step. Write that again. Write that step again. And then what should you do? Take square root on both the sides. Take square root on both the sides. So now this will come as it is equal to 11 into 11. So the square root of 14,641 is equal to 11 into 11, which is 120. Very good. Steps must be exactly what is on the screen or on the board. Seven to the power 4. Yeah, you can. You want to write it as 14641 is equal to 11 to the power 4, right? Then you will take square root on both the sides. So square root of 14641 is equal to, there are 4 11s. No, half the number of 11s will come out. 11 into 11 into 11 into 11, 4 11s. So what is half of this number 4? 2. So 2 11s will come out. So 121. Yeah, you can. But because it is, squares and square roots, we use the power 2. It's easy, like from 2 11s, 1 11 out. From 2 11s, 1 11 out. Did you correct it? Like, if you wrote 11 to the power 4, you should have corrected like this. Completed, Dhanvin and Srijit. Any questions, please ask me.
No, ma'am.
Okay. Next one. Now we learn the long division method. Okay. We learn the long division method for finding the square root of the given number 7,32,736. Okay, so we have these two methods to find the square root of a perfect square. You can use the prime factorization method. We use the prime factorization method to find the square root of a perfect square. If the number is an imperfect square, then you can find its square root approximately up to some decimal places using the long division method only. See, we have two methods, prime factorization method, long division method. Prime factorization method can be used only if the number is a perfect square, or if it is given that find the square root of this number using the prime factorization method, then that means it is a perfect square. So you use that method. Long division method you can use in both the cases, when the number is a perfect square or not a perfect square. Whether the given number is a perfect square or not a perfect square, you can use a long division method. If it's a perfect square, you will get a perfect answer. If it's an imperfect square, you will get it up to some decimal places, approximate value you will get. Because it will go on. The division will not come to an end, it will keep going. So you will stop. So approximately you can find the square root of the given imperfect square. Shall we start? Okay. Okay. So for finding the square root of this number using the long division method, place the number like this. Place the number like this. Yeah. This is the first step. Okay. Don't write anything. Listen to me first. Now, group the digits in pairs from behind. That means from backwards. Group the digits in pairs. Renda group pannu. From behind, backwards. So 6 and 3, that means this will form a pair. 2 and 7, this will form a pair. And this one. Now supposing the number was 3, 2, 7, 3, 6 like this. So 3, 6, 2, 7, 3 will stand alone. 3 will stand alone. You should not pair like this. You should not pair it like this. 32, 73, 6 alone is wrong. 32, 73, 6 alone is wrong. You must pair from behind. From behind. 36, 27, 3 alone. Okay. But here, since we have 6 digits, we have equal pairs. Yeah. Okay. Now, the first pair is 73. The first pair is 73. Now, we are supposed to use these tables. 1 into 1, 1. 2 into 2, 4. 3 into 3, 9. You can use only these products. Okay. So 4 into 4, 16. 5 into 5, 25. 6 into 6, 36. 7 into 7, 49. 8 8s are 64. 9 9s are 80. Now the number is, no, we cannot write 10 tens. No, you cannot use 2 digits at a time. So you can use only these products. Now we have the first pair 73. Do you find this number 73 in the products here? No. Then which is the product just less than 73? Yeah. In the products here, 1, 4, 9, 16, 25, 36, 49, 64, 81. We don't have this number 73. Then which is that number just less than 73? 64. 64. So what is 64? 8 8s are 64. So see here, 8 8s are 64. Like this you must write. 8 8s are 64. Got it? Now subtract. As always, subtract. 73 minus 64, 9. Now, after subtracting, after getting the remainder, bring the next pair down. Bring the next pair down. Bring the next pair down. Next step. See here. What do you have here? What do you have here? 8. Double it. Double the quotient. Say, double the quotient. Whatever is in the quotient, double it. Meaning multiply by 2. What do you see in the quotient? 8 into 2, 16. Write that 16 here. Write that here. After that, put a dash here and a dash here. I'll repeat. You will understand. I will see it once again. Okay. Maybe I'll just come again. So we understood 8 8 are 64, 9 is a remainder. Bring the next pair down. Double the quotient. 8 2s are 16. Write it here. Put a space, dash here and a dash here. Now we will have to fill these dashes. But in the dashes, whatever digit you put here, you should put the same digit here. If you put 1 here, you should put 1 here also. If you put 2 here, you should put 2 here also. 3, then 3 here. You cannot write different digits in the dashes. In the 2 dashes, you must write the same digit. Okay, that's the rule. Now the next rule is, see, supposing I put 2 here. I should put 2 here also. Now I should write a product here, right? See, that's what we normally write. See here, what did we write? 8 is 64. We wrote a product here. So here also you should write a product. So which product should you write? 162 into 2, not 82. You must find the product 162 into 2, not 82. 162 into 2. What is 162 into 2? 162 into 2. 2 to the 4. 12, 1 carried over, 3, 324. No, that's way less than 927. That's way less than 927. So we'll try 163 into 3. Because, yeah, now we'll check 163 into 3. 163 into 3. 163 into 3. Okay, so I'm lazy. So 163 into 3. 489. 489 is also less, na? Very less than 927. So we'll try 4. So we'll try 164 into 4. What is 164 into 4? 164 into 4? 656. Okay, we are getting closer, but we'll have to go ahead. 165 into 5. Are you following? 165. 165 into 5. How much? 825. Correct. Okay, we'll just try one more. 166 into 6. 166 into 6. 166 into 6. 996. Correct. 996 is beyond 927. 996 is beyond 927. So we have to stop. So you should not be doing, you should not be finding so many products. You should be able to gauge it. I'm not saying you should work like this. You should be able to gauge. You should directly try to go to 165 into 5. Yeah. Okay. So this just for you to understand. So the number which is, you don't find 927 here. If you find 927, you can take that. But we don't find the product 927. So which is that product which is just less than 927? 825. And that is 165 into 5. And that is 165 into 5. So 165 into 5 is equal to 825. See, very easy. See, 165 into 5 is 825. Write the product here. Now subtract. Subtract. 7 minus 2, 2, 0, 1. After getting the remainder, bring the next pair down. Yeah, bring the next pair down. Okay, now double the quotient. So remainder, then bring the next pair down, then double the quotient. What do you see in the quotient? 85. In the quotient, 85, double it. 170, write it here. 170, write it here. Now again, put a dash here and a dash here. No, double the quotient. Quotient should be this one. The numbers here. Double this one, not this one. Yeah. Now find all of you. Now whatever digit you place here, you should place the same digit here. So if it's 2 here, 2 here, 3 here, 3 here. Now for you, for this one, I'll just tell you a trick. Now this is assuming it's a perfect square. Now it ends with the digit what? 6, right? So it should be a perfect square. It should be meaning it may be a perfect square. Yes or no? Because numbers ending with the digits 2, 3, 7, 8 are not perfect squares. This one ends with 6. Now, when will you get 6 in the ones place? 6 in the ones place. 4 fours are 16. You have 6 in the ones place. Or 6 6 are 36. So in these two dashes, you can either take 4 or 6 or 6. You should try 1704 into 4 or 1706 into 6. Because 4 into 4 is 16 or 6 into 6 is 36. Because this is the concluding step. See, I have many things to share. 1 minute. Because this is the last step. See, in this step, you should not see the last digit. In the last step, this is the last step. We don't have any more pairs to bring them down. Because it's the last step, what's the digit here? 6. So 16 ends with 6, 36 ends with 6. So that means 4 into 4 or 6 into 6. So 4 and 4 or 6 and 6. So it is 1706 because if you add 6 here, you should add the same thing here. 1706 into 6. So 1706 into 6. 1706 into 6. One second. So 1706 into 6 is equal to 10236 and the remainder is 0. So therefore, the square root of 7,32,736 is equal to 856, which means 856 into 856 is 7,32,736. Yeah. All this rough work also you should take down. Please take the rough work. All of you must take the rough work. Right. Yeah. I saw. Nothing. Shreejit, disable your mic. Yeah, is it over? Shreejit and Danvin, finish writing here, all of you. Yeah.
Ma'am, I'm writing tables, ma'am.
Okay. Yeah, done.
I'm going to, ma'am.
Yeah, it's time. Yeah. Okay, that's it, Shreejit. You have to take a screenshot and complete it later. Okay. Find the value of, so see here, find the value
Okay,
of,
ma'am.
okay. Find the value of the square root of 81,225 using the prime factorization method and long division method. Quickly do prime factorization method. We'll do the long division method together. Prime factorization method, you can finish it here. For yours. No, you cannot. You should have pairs of equal factors. No, you should check. You should not give up. The question is correct. You should not give up. Try again. You might have gone wrong with the division. Do it all over again. Online students, Dhanvin, Srijat.
Ma'am?
You want to? Yeah. Have you completed the prime factorization part?
No, ma'am. I'm stuck on 361.
Okay.
Ma'am, on 361, any number is not working with it.
No, you should go ahead. If yeah, you're right actually. If you've got 361, you're right. Just go ahead. Meaning go ahead, meaning you would have tried maybe like 7, then go on, 11, 13, go on. Okay. No, he said he got 361 done with. 361 looks correct only. What did you get, Navneet? What's the last number you got in the division? 31 is wrong. You? No, 100? No, darling, that's right. Yeah. Yes, Srijit, you said something?
Ma'am, is it 19?
Very good. It's 19.
No, I thought that's
The final answer 19? The final answer. We are talking about the prime factorization.
your voice is not clear, ma'am.
What? How are you getting such big numbers, Navneet? How are you getting? Show me a book. Oh, okay. Pardon. You got 361 now?
Yes.
361 is not divisible by 2, 3, 7. Right. Divide 361 by 11 and try. Then if it's not divisible by 11, the next prime number, 13, try, divide by 13 and try. Not divisible, then the next prime number. Go on like that. But at this point, you can use a shortcut. It ends with 1. It ends with 1. Yeah, so it should be,
Ma'am, is the answer 285?
perfect. 285 is the correct answer. Yeah, you finish it. We are talking about a different part. Divided U. That's fine. Okay. Okay. 81225. You are telling me here. Navneet, you started with which number? You started with 5, is it? Okay. So 5. What's the quotient with 5? 1, 6? Then what did you do? No, next, Avinish. You, Anirudh, correct?
Yeah, 3 to 4 9.
When you divide by 5, 3249. Then next, 3. What's the number? What's the quotient? 1, 0. Then you took what again? 3. Huh? Yeah, so see here, what is 361? Nineteen into 19 is 361. And since 19 is a prime number, you should hit 19 straight away. It's a prime number, so you should write 19 straight away. 19s are 19 ones are. So only Dhanvin has got this. He was able to finish this. So now what are the steps? What is the step? 81225 is equal to 5 squared into 3 squared into 19 squared. Now repeat the step. 81225 is equal to 5 squared into 3 squared into 19 squared and take square root on both the sides. Write this as it is. Square root of 81225 as it is equal to from 2 5s 1 5 1 3 119. So square root of 81225 is equal to 5 3s are 15, 15 into 19, 15 into 19, 285. Yeah. Finished? Srijit?
I'm going.
Now get ready for the long division method. Place the number. Place the number in that format. Online children, take a screenshot so that if you have not finished, you can complete it. Yeah. Now, We'll find the square root of this number using the long division method. So you'll have to pair the digits from behind. 2, 5, 1, 2, 8 stands alone, correct? Yeah, do that. Now the number is 8. The number is 8. 1 into 1, 1. 2 twos are 4. 3 threes are 9. 3 threes are 9. 2 twos are 4. 2 twos are 4. Because 1 into 1 is 1 into 1 is 1. 2 twos are 4. 3 threes are 9. But this is 8. So 2 twos are 4. 2 twos are 4. What's the remainder? 4. Next step, bring the next pair down. Then double the quotient. Double the quotient. What do you have in the quotient? 2. Double it. 4. Write 4 here. Then a dash here. Place a dash here and a dash here. Now, whatever you add in this dash, whichever digit you write here, the same digit you must write here also. So if you write 41, see, if you put a 1 here, you should put a 1 here. Then the product is 41 into 1. Not 41 into 21, 41 into 1. 42 into 2, or it will be 42 into 2, or it will be 43 into 3, or it will be 44 into 4, 45 into 5. So check which product. Check if you can get 412, or you should find the product just less than 412. Yeah. Yes.
Ma'am, is this long division method?
Yes.
Ma'am, can you repeat that? Repeat that sums.
Oh, repeat the steps. Okay, I'll do it. Let me just finish this and do it again.
Okay, ma'am.
Where is 55? Forty? 48 into 8. What is 48 into 8? 384. Okay. So 48 into 8. 384. What's the remainder? 28. Next step. Don't say last number. Bring the next pair down. Get the next pair down. Then next step. Double the quotient. What do you have in the quotient? 28. Double it. 56. Yeah. Write 5 here. Yeah, try. Because it's a last step, you can use that, that idea. Yeah, 2825. Did you bring the next pair down? Five 65 into 5 is 2825. So 565 into 5 is 2825. So therefore the square root. Sorry. Yeah. $40. Okay. Bring bottle. Go get your bottle. There's your bag. Okay. We'll see it again. Srijit, ask your doubts. Yeah, ask your doubts. You must focus. I did the first one very slowly. Okay. What's the first step? Group the digits in pairs from behind. From behind, like this. 2, 5 makes a pair. 1, 2 makes a pair. 8 stands alone. So the first step is to group the digits in twos from behind, backwards. Okay. Next. 1 into 1 is 1. 2 into 2 is 4. 3 into 3 is 9. It's more than 8. So we'll have to go with this one. We'll have to go with this equation. 2 into 2 is 4. Subtract. Bring the next pair down. Double the quotient. We have 2 here. So double it. 2 into 2, 4. Write that here. Place a dash here and a dash here. Now, whatever digit you place here, you must place the same digit here. And you must get the product as 412. Or you should find the number just less than 412. So if you place 6 here, you must place 6 here also. Then the product is 46 into 6. So what is 46 into 6? 6 6 are 36, 3 carried over, 6 4 is 24, plus 3, 27. No, it's way less than 412. So let's try 48 into 8. 48 into 8. Whatever digit you place here, you must place the same digit here. So it will be 48 into 8. 8 is a 64. 6 carried over. 8 4 is 32. 38. So let's try 49 into 9. Let's try 49 into 9. 9 9s are 81. 8 carried over. 9 4s are 36. Plus 8, 44. This is more than 412. So we have to go with 48 into 8. So 48 into 8 is 384. Now subtract 28. Bring the next pair down. Double the quotient. 28 into 2. The quotient is 28. Double it. So 28 into 2, 56. Again, whatever digit you place here, place the same digit here. This is the last step. So, and you see that this number ends with the digit 5. So it has to be a 5 here. 5 5s are. Because 5 5s are only can give you a 5, 25, 5 in the end. No other number can give you 5 in the end. So you can directly try 565 into 5. 5 5 are 25, 2 carried over, 30, 32, 3 carried over, 28. 2825. And if it's a perfect square, the remainder should be 0. If it's not a perfect square, all the digits would have, got exhausted, but the remainder will not be 0. That means it's not a perfect square. Yeah. There is a procedure to continue. We'll learn that later. So please practice, all of you, this method. All right. I will be giving you some, numbers which you can try as homework. Yeah. Don't do by the prime factorization method. Do only by the long division method. Prime factorization method, you can try it as homework. No, now, class work. Find the square root of the following by prime factorization method. Don't do it now. You can finish it as homework. Just do the long division method now for the first number. Yeah, for all the numbers, take the first number first. Yes. Do it now. Long division method, do it now.
Come for every sum.
Yes. Prime factorization method, you can finish it as homework. Long division method, do it now. Take the first question and find the square root by the long division method. Work independently. Don't discuss, so that we understand, like where we are not sure or not clear. Sorry? Show me a book. Double it. 1 into 2. Double means what? You should multiply by 2. How will you double a number? Into 2. Hmm. 1 into 2. Not square. 1 in double it, I said. Squaring is different from doubling.
Ma'am, doubt.
Yes.
Ma'am, the first number is 2, ma'am. It's not square of any number. So what should we write for?
25921. Yes. Take the closest product. 1 into 1 is 1. 2 into 2 is 4. But this is 2. So which is the, you don't find 2 here. So which is that number just less than 2?
1.
1. So it is 1 into 1 equals 1. 1 ones are 1. You must just write this equation here. See here. 1 into 1 is 1 more. So write it here. 1 ones are 1. Subtract. Should have paired it before that. Yeah. Go on. If you have a question, you can ask me. Yes.
Ma'am? Ma'am, the answer is 161, ma'am.
161.
Is that right, ma'am?
No. 161, huh? Okay.
Yes, ma'am.
With a calculator or you worked it?
Ma'am, I worked it, ma'am.
Okay, send the image on WhatsApp. You're right, send the image on WhatsApp.
Okay, ma'am.
Yeah, correct.
321. 16 into 4. Something.
Okay, now see here. Yeah.
Ma'am, I sent it, ma'am.
Yeah, Srijit, okay. Send the photo of the earlier page also, Srijit. Earlier pages of today's class. Yeah. Yeah, go on, go ahead. So 1 ones are 1, 1 is a remainder. Then what? 5, 9. The next pair comes down. Then double the quotient. 1 into 2, 2. Whatever you place here, you should place the same digit here. 26 into 6. 156. 156. What's the remainder? 3. Bring the next pair down. Double the quotient. 16 into 2, 32. Whatever you place here, you must place the same things here. So you should place 1 here and 1 here also. 321 into 1. 321 into 1 is 321. And the remainder is 0. Therefore, square root of correct 25921 is equal to 161. Srijit is because you're not able to write fast or maybe you're tired or something. Is somebody else writing for you? Are you? No. Is somebody else helping you to write because you're tired or something? Or you're slow?
My mom helped me, ma'am.
Oh, that's your mom's handwriting, no?
Yes, ma'am.
Ah, that's what. I asked you to send the earlier page to compare your handwriting with, because I could make out it was not yours. That's okay.
Ma'am, but I only said the answers for
Yeah, that's what I said. So you dictated and your mom helped you to write it. That's what
Yes,
even I
ma'am.
understood. Yeah.
Okay, ma'am.
Okay. You're in the first one or the second one? Yeah, what's your doubt? Okay. No, double the question. Yes, please. Correct.
Ma'am, second one answer I found.
What's it?
41.
Correct. Go on. Next one. Show me a book, Anirudh. No, don't get it. Oh, you finished the first one, is it? Okay. Yeah, now show me your book. You have not placed the digits correctly. Where have you put it? Should come here, no. Beside 159, you should write. You have not written anything beside 159. There's nothing beside 159. Do check. I know. Please check what you've written. Can you see the number 159? What have you written beside that, to the left side? What have you written? In the margin, like this is 159, right? What have you written here? Where have you written? That's not in the right spot. So, tell him, no? Strike it out. Don't correct it. No. Do it again.
Ma'am, the third question, ma'am. First answer is 3 into 3, 9, ma'am. Remainder is 1, ma'am.
Remainder is 2.
Yeah, 2. 3 into 3, 3 into 2 is 6, ma'am. But 61 into 61 itself is more than 300 something.
They should put 0.
Okay.
Show me. Then at the end of every division, you must write this. Square root of 25, 920. See here. At the end of every division, you should write this. The square root of, yeah, very good. The square root of whatever number is, or was the answer.
Ma'am, but still it's 3,600 something.
Yeah, we'll do together. Yeah. I've written 2 eights. Have you written 2 eights? How can you write different numbers? Huh?
Ma'am, the answer of second one is 41, ma'am.
Correct.
Okay.
Recall the procedure. Don't simply keep doing that. How do you start? Yeah, then after that. One into one, 2 into 2, 4. You must use such numbers only, such equations. Not the regular multiplication tables. 2 8s are 16. Yeah, we'll do the third one together. Yes, even Dhanvan was asking me. The third one alone we'll do together. Yeah, 1 minute. We'll see how far you're right. We'll see. Yeah. Show me your book. Correct. So when you double the quotient here, you'll get 4 into 2, 8. Whatever you place here, place the same thing here. 1 and 1. 81, 0. So therefore, square root of 1681 is equal to 41. We'll work the third one, that is C, and wind up the session for today. Okay, let's group it. 4 9 7 6 1 1. So group it from behind. Group in pairs, in twos from behind, backwards. So 49, 76, and 11. 1 into 1, 1. 2 into 2, 4. 3 into 3, 9. 4 into 4, 16. So this is 11. So 3 into 3, 9. 3 into 3, 9. Subtract 2. Bring the next pair down. Next what? Double the quotient. Double the quotient. 3 2s are 6. Into 2 you should do. 6. 3 2s are 6. Then place a blank space here or a dash here and a dash here. Okay, so 64 into 4. 64 into 4 is what? 256. What's the remainder? 20 is the remainder. Then you should bring the next pair down. This is the last step. This is the last step. and the number ends with the digit 9. It is 3 3s are 9 or 7 7s are 49. Okay, what's after this? Double the quotient. What is 34 into 2? What? 168. 34. Double the quotient. 68. Yeah, so it has to be 683 into 3 or it has to be 687 into 7. Because only these two can give you a 9 in the units place. So it is 683 into 3. 3 3s are 9. 24 2 carried over. 20. 205. So then you should finish it like this. Therefore, square root of, have you written that? Show me. 1,17,649 is equal to 343. Where, yeah, where did you go wrong? I'll see your book. I didn't get to. Okay. Huh. Oh, double the quotient you went wrong. Okay, 3 2s are 6. You wrote it as 9. Yeah. Okay. Dhanvan and Srijit, any questions?
No, ma'am.
All right. All right, children. So that's it for today's session. I'll share the homework questions on WhatsApp. I'll give you the instructions on WhatsApp. Thank you, children. Online children, you may leave the call. Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.